Hello everyone, and thank you for joining today's webinar. My name is Donna Gordon and I'm part of the professional development team here at IISM. Before I hand over to Justina, I'm going to run through a few things with you. So to begin with, you should see to the right of your screen a toolbar with various options. You will be on mute for the duration of the webinar, but feel free to ask any questions, make any comments using the question area, and we will take 5 to 10 minutes at the end to respond to these questions. If you need any support using GoToWebinar, the I symbol will take you to the support site. Finally, this webinar is being recorded and a copy of the recording will be placed on the IISM YouTube channel after the event. So that's enough for me. Justina, I'm now going to hand over to you.
Hello everyone and welcome to today's session. So for the start, I would like to thank Owen Duffy from Hilti, who came along with us to deliver this webinar about fire safety. We appreciate the time and effort put in personally by Owen, our presenter, for the benefit of this webinar. So Owen Duffy is a mechanical engineer by trade. He joined Hilti HQ in 2018, moving to Ireland in this year, March 2021. Owen has begun working as a key project engineer, providing designs, application advice, as well as seminars in the MEP supports and fire stopping trade to design consultancies and contractors. The webinar will focus on the fire compartmentation, product testing techniques, and other fire stopping options available in the market. I am happy to pass on to Owen. Thanks everyone for joining, and if you have any questions, please use the chat. Owen?
Thank you, Justina. Hi, everybody. Thanks very much for having me here. It's a pleasure to be here. I'm going to share my screen straight away so you can see it now, hopefully. Hopefully you can hear me all okay. So yeah, as Justina said, I have a background in mechanical engineering, and I began with Hilti in 2018, working in their headquarters, and I've moved back to Ireland as a key project engineer, particularly working in Firestop as well. So the focus of the presentation today will be on Firestop products and service offerings that we provide in passive protection. Now that's a bit of a complicated few sentences, but I will explain it. I'll break it down as simply as possible. Unfortunately, I won't be able to share videos with sound today. I didn't realize that was an issue, but we'll be able to run through a lot of the stuff. We'll break it down quite easily for you. And what we will do, I think we agreed beforehand that we will ask the questions at the end. Maybe if you can send them to Donna and Donna can call them out. And if not, you'll be able to email me afterwards. I'll share my email after that. So just a quick background on Hilti themselves. Sorry, no, it's gone. Yeah, so sorry, so Hilti is one of the world's leading professional construction service providers. We're a family-owned group based out of Shan and Liechtenstein, a small principality in between Switzerland and Austria. There's approximately 30,000 employees worldwide. We invest heavily in research and development to make sure that we come out at the forefront of innovative products, and that's really our promise, that we will keep providing innovation in the professional construction industry. Like I said, we offer a wide range of services. We're very commonly known for our power tools, for our Hilti guns that a lot of people would be familiar with, but we offer a wide range of services. And what we're going to focus on today is fire stopping systems in particular. So the agenda for the presentation will be the following. We're going to talk about Firestop compartmentations, talk about product testing and regulations, and then actually how to Firestop these different penetrations that we may need to Firestop. It won't last more than an hour. I'll try to keep it as short as possible. I think the human mind can only last about 18 minutes of an attention span, so hopefully I'll be able to maybe a little bit longer, but hopefully you'll be able to tune in as much as possible. So firstly, the video that I had here basically just highlighted the importance of fire protection measures. There's about nearly 4 million fires that occur worldwide every year. Everyone thinks it's never going to happen to them, but you hear sirens on the roads, the fires do happen. You know, so there's a huge amount of deaths that occur per year, and fire stopping is now becoming a highly, highly important issue in the construction services and managing risk management. Interestingly, it's not the flames, it's not the heat that causes most of the deaths. It's smoke, cold smoke normally, that causes a lot of these deaths that happen throughout the duration of a fire. Most of the deaths don't occur in the room where the fire started. It's the spread of the smoke that that causes the fatalities. And yeah, it's amazing when you see so many videos, just how quickly it spreads. It just, if ever there's a feeling of being out of control when you see a fire, that's just shows how important it is to make sure that we manage these fires and compartment them. So when we talk about fire safety strategies and we talk about evacuating buildings, there's a different range of elements that is composed when dealing with fire evacuations. So first of all, we have fire detection and alarms. We have fire escape routes for building users to exit the building, and we have fire suppression in the form of sprinklers or fire extinguishers. All of these are of little use when there's a raging fire taking place through a building. Sprinklers can only go so far in suppressing a fire. What we want to do is focus on fire compartmentation and actually stopping the spread of those flames going into the next room. So when we talk about fire compartmentation, it's life safety, and it also obviously limits the damage to a building. So it's asset damage limitation as well. So when we talk about Firestop compartmentation, this was one of the key topics that we wanted to talk about on this seminar today. When we talk about fire compartmentation, we're trying to form tight boxes from the products of combustion. So the products of combustion are heat or flames, smoke, and toxic gases. So we want to form tight boxes or seals within each room to make sure that fires won't spread. But if these walls are fire rated, how are they actually spread? Well, every room will have penetrations made through it in this form of cable trays or pipes or other services. And what happens is those fire rated walls, when pipes and cable trays go through those walls, then the fire rating is breached. So the fire wall becomes not a fire rated wall at all. It's not rated. So what we need to do is reinstate that fire rating to make sure that it remains fire tight. So what that does in turn is it does save lives and property in return for that. So seeing here in the actual at the top right here, we have an image of one of our products, our fire foams. So that's just a way of we can fire stop some of these penetrations, but I'll talk about that in more detail later. Next, we'll talk about fire product testing and regulations. So when we talk about product testing, it's an extremely stringent measure that our products go through. It's based on three main criteria: the load bearing capacity or stability. So you see here in this diagram, say if this is a fire stopping product that Hilti has, it has to withstand throughout the duration of a fire for a certain amount of time. So it measures the structural stability of the product. Integrity makes sure that the product can withstand the effects of heat and gases throughout the duration of a fire. And then insulation. So this measures actually how long will it take for the non-fire rated side to reach 180 degrees. So we have to insulate the heat. So we have to stop heat transfer. So the other side of the wall won't reach 180 degrees. So a lot of products, you might see a wall. We get a lot of customers saying, okay, I need a fire rating of 90 minutes. So that product will be EI 90, it's called. So it has to withstand the fire for 90 minutes. So the E stands for integrity. So it'll be able to prevent gases and flames passing through it for 90 minutes. And then insulation. So it can guarantee that the other side of the wall, or the non-fire side, will not reach 180 degrees for at least 90 minutes. So that's what we do. What's what we talk about when we talk about fire rating. So I hope that is clear for you. Additional testing these products go through is explosion resistance, acoustics, water resistance, and seismic as well. So they go through stringent testings, and some would have to be catered for particular products if they're being used in environments where earthquakes are common, or nuclear plants where explosion may occur as well. So this is an example of a building I just put up here. I think it's interesting. So when things actually go right, this was a laboratory in Wilton in the UK. It was a lab here in the corner that I think it's something self-combusted with inside it overnight. And what happened was the fire spread, but it stopped, thankfully, because they had the right Firestop implementation in place. So if you actually look as well, you'll see on the other windows, lights are actually still on in the building. So the cables, everything it basically worked to plan. The fire where it broke out stopped where it broke out, and it didn't spread and destroy the whole building itself. This is a video I'm going to share without the sound, but I think it is good. It just shows you visuals. I can only hear it myself, but this is our Firestop testing facility in Germany. This is where we test our Firestop products, and we also have one in the USA as well. So I'll commentate while the video is ongoing. These are some of our Firestop products that we test in these manufacturing facilities. So they go through a furnace for a certain length of time. You'll see they're exposed to high temperatures for a long time. And so they're installing them. We'll have different types of penetrations: plastic, cables, metal pipes. So this is them going into the furnace, and the products are tested for our own interest to see how these actually perform. So as these products are exposed to high temperatures, certain products like the plastic will disintegrate naturally. And what happens is these products will form seals, so that it'll be sealed shut tight and the fire won't spread to the other side of the room. So I'll explain this in more detail, but I think it's a good visual to show you how these products are tested. So you'll see as all these pipes disintegrate under high temperatures, the fire is actually stopped because of the material in our Firestop products have sealed tight the penetration. And then when firefighters come in and have to quench these buildings, they're exposed from hugely high temperatures to extreme cold temperatures. So the actual testing is, or the actual pressure, environmental pressure that these products go through are huge. So yeah, I think that's enough to show you. This is the result of it from the furnace side, and then on the other side, the fire hasn't stopped, or the fire hasn't gone through. So what is the difference between European and national standards? So now we're going to talk about the actual testing itself. So the old route, the national route, was the only thing that was tested was the actual product's ability to resist fire. That was it for the national route. Whereas now with the European route, it's a highly stringent tests that are made. It's not only fire now that the products are assessed with, it's their serviceability throughout their lifetime, and their durability, and their ability to withstand different types of environments. The European route offers third-party control, whereas the national route has no third-party control. Our products are third-party approved, which means that there's no bias and they are extremely stringently tested. The European route means that it has to be accepted throughout Europe, whereas the national route is only accepted within their own country, or unless they have mutual agreements with other countries. So that's the difference between the European route and the national route. So the European route is the way we go, and what we get from that is called an ETA, or a European Technical Approval. So this is what our products, most of our fire products have. Our products will have approvals, but most of them will have ETAs, European Technical Approvals. And what that means is that you can guarantee that a third-party body has approved this and said this product will withstand fire for 90 minutes or whatever the product says it will last for. So the CE mark here is not actually a quality mark. It might confuse people, but it's actually it means that it has an ETA and is third party approved with a certificate of conformity. And yeah, we also have other standard approvals, but our products, this is where we really are at the forefront of our designs. All of our products have approvals, which when customers go to buy fire stopping products, at least they know now that it's third party approved, and that if their clients want to sign off, then they'll know that they have been tested. So the advantages of an ETA are huge. There's obviously increased safety and proven reliability of the products themselves. It's transparent because it's an independent test. It complies with EU regulations, so it's completely in line with conformity standards. And it has the reliability and quality. And like I said, we have an extended scope of approvals. So moving on into our next section, I want to talk now about that video that we saw earlier about how to fire stop different penetrations. So firstly, we'll talk about fire stop building joints. I won't spend too long on these, it's just different examples. So if we're talking about here, you'll see at the bottom picture, you'll have a wall to a floor, to a concrete slab. So that's a building joint. Or here at the top, you'll see a slab edge to a facade. So they need to be fire stopped because you'll have cavities there. And if there's a fire below, then if the fire starts in the lower floor, then the flames will spread to the next floor. But this is how we fire stop it. So when we talk about fire stopping building joints, two main components, mineral wool and a sealant. So on the top, we're using our speed spray, which is almost like a liquid sealant that forms a seal. Or then we have our mastic, which also it goes, so you see the mineral wool packed in first, and then you have your sealant. So you have either your mastic or your speed spray, depending on the application required. And then here's just a picture of our instructions for use, but I don't want to overcomplicate things too much. Fire stopping plastic pipes. If you held a straw in your hand and you put a fire lighter or cigarette lighter up to it, that straw will disintegrate. It's the same when a plastic pipe is exposed to high temperatures. That pipe, like you saw in the video, completely disintegrates. So if you see here where this person has their gloves around this pipe collar, when the pipe disintegrates, what happens is an intumescent material, which is within the pipe collar itself, will start to expand. So an intumescent is basically material that will expand when exposed to high temperatures. So you see this is an intumescent material before being exposed to heat, and then this is it after. So what happens is it actually forces itself closed once the pipe has disintegrated and stops the actual spread of fire into the next part of the wall. Yeah, and you see an image here of this is the intumescent material exposed after 1 hour, and then after 2 hours of being exposed to fire, it completely expands. So this is different products that we have for fire stopping plastic pipes. We have our Firestop collar, and then we have our Firestop wrap. And see that when it's tight in against the wall itself, the pressure it causes will actually close the pipe tight. So then we have our endless collar as well. This would be normally used for more complicated designs where there's elbow pipes or pipes that are on an incline that need to be fire stopped coming through buildings. And then we have our cast-in devices. So when products or when when foundations are being laid for buildings or slabs are being poured, that we can have cast-in devices that are pre-made and will stop the need for cutting through concrete slabs after that. So fire stopping metal pipes, again, if you held a knife up to your hand and you lift the metal, the heat transfer will come down to your hand eventually. So what we want to do is, it's not actually that the metal will disintegrate or the pipes will disintegrate, but they will get extremely hot, and that heat will transfer to the next room, and though that's when the next room will actually catch fire, because whatever is touching that then will catch fire. And that will happen. So especially the heat these products are exposed to are extremely high. So it's not the like I said, it's not the actual integrity of the product we need to worry about, it's the heat transfer. So here we need insulation. So these are our different products that we have for insulating pipes. So we have fire stopping wrap, and then we have a fire stop bandage. So the wrap goes basically, it's very simple, it goes around the pipe and then in through the penetration, where a fire stop bandage goes around pre-insulated pipes. So here we'd have something like Armaflex insulation on a copper pipe, and then what the fire stop bandage does is that will expand as this insulation burns out. This is when our bandage will take over in the to stop heat transfer. Fire stopping cables can be a little bit more tricky because cables just tend to vary in so many ways. Some cables may have a lot of copper and little insulation, so that's an issue. And then there may not be too much copper, and then a lot of plastic around the pipes. So that's where integrity is an issue. So the plastic will burn away. So we need to make sure that we get the right solution for that. And these are our different types of solutions. We have our cable bundles, which these are like our cable discs that wrap around cable bundles. It's a simple little, it's like a plaster that sticks around it. Or we have our intumescent sealants that can go around small cable bundles. Then larger cable bundles, we have products like the cable collar and plugs, and our speed sleeve, which I'll talk to you in more detail about. And then for mixed penetrations, we have our Firestop blocks or our coated board. And these are just different ways that we can Firestop these different penetrations. This is a lot to take in one slide, so I'll just break it down for you. I just wanted to mention about our speed sleeve here. This is probably one of our most innovative products. This will be going into a lot of data centers around the country as we speak. It's basically a product that, if you see it here in the image, it goes through the penetration, and what happens is any user such as an electrician that's passing cables through will be able to pass it through this opening here. And what it does is it's a twist and close mechanism that basically seals it tight and stops the fire spreading. So the advantage of these products of the speed sleeve product is that it's a fiber-free environment. When we talk about coated board, it's basically it's a highly it produces a lot of fibers and dust, and in data centers, hospitals and clean rooms where basically dust just can't be an issue, something like this becomes very, very useful. It's very simple to use, it doesn't require huge technical ability, and there's easy inspection as well, post installation. Yeah, so this is mixed penetrations examples that you may have to fire stop here. So you'll see this riser here that needs to be fire stopped. So this is a challenge when all of the services are combined together. And here we have parameters that we need to take into consideration when we're fire stopping mixed penetration. So we need to know the distances between the services and take into account the interaction between cables and pipes and what that does. So we have testing for each one. So when I have customers coming to me saying, can you fire stop this? I need to know, they'll just send me a picture and say, can you fire stop this? And I'll reply to them and say, well, I need to know the distance between the actual edge of the concrete and the penetration itself, the thickness of the pipe you're trying to fire stop. All of these different parameters need to be known before we come up with the correct solution for fire stopping. So product cost versus installation cost. The more basic products tend to have a higher installation cost. So our coated board and our mortar. So the coated board this is an example of it here. This is what I was talking about that has, has a lot of fibers and dust. So the more basic, the more complications there is in installing. As we go into the more premium product range that we have, such as our Firestop blocks, which is basically this flexible block that will be able to be cut and put into these penetrations. So that's, as I said, as we go into the more premium side of things, installation becomes less of an issue. So what we want to focus on is not charging people more, it's making sure that the productivity is there. So making sure that you are able to install these in the most efficient way possible, and that the installer, when they're using this, is that they're not exposed to fibers constantly, because when the installer is actually installing these coated boards, these fibers can become hazardous, especially over a long period of time, and users are only actually able to be exposed to a certain amount of dust for a certain length of time. So this is just an example of the different range of products. So how do we install to be compliant? We need to make sure that the product can be used and is in accordance with an ETA, or the European Technical Assessment, as I said earlier. This is for the design stage, so this is what we need to know. Like I said, what's the fire rating you need? Is it 90 minutes? Is it 120 minutes? What's the type of penetration size? And what's the material? Is it, say if it's a pipe, is it PVC, PVCU, HDPE pipes? We need to know all that, and then we look at our ETAs, and then we'll be able to say, okay, well, this will be the product for you, or whatever. Another way to be compliant is that you take a photo before installing the Firestop product, and you follow the instructions for use. It's incredibly important that people follow the instructions for use when they're installing these products. Just personally, this year, we had an issue on site with a customer that installed coated board around their through their penetrations. A fire engineer on site requested destruction tests on 3 of these coated boards, which basically means destroy them. So we see how they were installed. They were destroyed, and what happened was the fire engineer realized that the mastic to actually seal these coated boards to the edges of the penetration, the mastic wasn't actually it wasn't used, so that actually what the mastic does is stop the smoke spreading. And it turns out that they destroyed 3 of them, but there was 4,000 openings made of that similar type of penetration. So what it did was it threw everything into doubt and weren't installed correctly because the instructions for use weren't followed. So it has a huge impact. So also to take photos after the installation as well is really important, so we can document how these were installed. And finally, the last part of the presentation is talking about Hilti's fire stopping services and our technical support around fire stopping. So our sales team have basic fire stopping training within our Firestop range. So they'll have a basic understanding of what you need or what the customer needs. Engineers, we have a bit more of advanced training in the sense of we'll be able to provide technical approvals, we'll be able to read technical approvals and make sure that the customer is compliant when installing the products. So if there's a situation where there's a very unusual penetration, not highly unusual, but if there's penetrations where we have no test data specifically for that penetration, we may need what's called an engineering judgment. We call them EJs. And what that does is allows us to extrapolate a lot of different approvals that we have. And we have a fire engineer based in the UK, in Manchester, who will be able to basically make a call on, from all of our tests, we can say, yes, this is possible, no, it's not possible. So we provide engineering judgments for our customers as well. We attend site and do inspections, and we can give training to installers and provide CPDs if necessary for them. So it's one of those things that Hilti offer that really there's it's a huge benefit to the customer that when they call us, we can be on site within that day and give them guidance on what they need. So without using any of our support services, anyone can use our Fire Selector. So if you follow that link there that I see on screen, this is a Firestop Selector application. So you'll be able to select the different type of penetration that you have, the base material that you have, and this software will be able to generate a suitable product, and you'll be able to download all of our technical documents and our data sheets and our approvals that we have for those products. So you see here an example of how that comes out. The Firestop Documentation Manager, this is a software that's very popular amongst Firestopping customers. It's basically where once you've performed the Firestopping penetration, once you've Firestopped the penetration, you'll be able to capture that penetration, and this goes to the cloud, so you'll be able to take a picture of the penetration, sync it to the cloud, and QR code will be able to document what you Firestopped. So this again is a video without sound, but I'll be able to talk you through it. So the fire engineer or the fire installer will be able to select different types of penetrations. He'll be able to, before he does it, input this into his computer. He will speak with the engineer, the foreman on site, and discuss where the penetrations have occurred. So this will be an example of a penetration here, and they'll capture that penetration. And what the QR code does is, once they scan it on the QR code, once they capture it, they'll be able to upload that to the documentation manager. And once it's captured, then that will be able to give all the details of that penetration itself. And what can happen is, after that, you'll be able to download professional reports to provide to the fire engineer, the independent fire engineer on site, so they'll be able to read where the penetrations have happened. Obviously, that was before COVID. So yeah, that's just a quick overview of our Firestop Documentation Manager. The preparation is back in the back office, where we create the project, and then we capture the penetrations and produce reports from that. That's just a quick overview of that. Finally, to talk about our BIM services. BIM stands for Building Information Modeling. So we can help you design, model, and plan fire stopping products for your BIM projects. So we'll need to know exactly the different types of parameters, like I mentioned before, like the pipe thickness, the penetration sizes. But once we have all these details, we'll be able to formulate a BIM design for your project, and basically have it all on the computer, so that there is no need to worry about what type of product you need. We'll be able to provide everything for you, as well as the detailed the approval details and the bill of materials that you'll need. So that obviously saves hugely on productivity and maintenance down the line as well. A lot of the projects that we deal with, a lot of the issues are concern of maintenance down the line. So inspections for these products down the line is a big thing. So maintenance as well is an advantage there, operation maintenance. So this is an example of some of our BIM projects that we use. So our modeling here, we'll know these different types of pipes, and we know exactly what type of cable collar, or pipe collar, apologies, is going through here. And we'll be able to say, well, this is the diameter pipe collar you'll need here, and here you'll need certain type of fire stopping foam. So that's just the different types of examples of our BIM services. And like I said, we'll need to know these list of parameters here that will help us decide which type of product you need. So yeah, and what it does is avoids human error and avoids clashes in the system. So this is the big advantage of the BIM services that we provide. So yeah, that completes the presentation. Try to keep it as short as possible, so that you'll be able to listen in, but I can take as many questions as you want now. If you don't have any questions at the moment but want to get in touch, my email is there. You're more than welcome to email me on any questions. If you think of them after, I can help. And if I can't answer any of the questions, which is possible, you can email me. You can give me your email, and I'll be able to get back to you on that. But thanks very much for listening. I appreciate it. and I hate listening to the sound of my own voice for that length of time, but hopefully somebody else can take over now.
Thank you, Owen. That was really great. So does anybody actually have any questions? By all means, just type them into the question box. Jim Kennedy wanted to tell you that it was a very informative session, and thank you.
Thanks, Jim.
Owen, if I could make a comment more so than a question. It's a very interesting topic and obviously very topical as well. And I think you really hit the nail on the head there early days. You mentioned the whole concept of fire compartmentalization is to give you that tight box, and that starts with the design early days as how we're going to go do that, through to the lads that are installing these materials. I said there can be issues with installers not being trained well enough to install some of these products. But the people that are on this call, you know, I was a foreman at one time myself in a former life, and you know, with the modern foreman needs to know so much about so many things, and I'd really have to question myself if I was a foreman today, would I know enough about fire stopping anymore? Like, it's moved on so much. And if I got the confidence to supervise that then as well, and obviously you guys are giving people the ability to be able to upskill. They don't need to know everything, but know where to lay their hands on this information, and this is something that you guys are offering as a free service.
Yeah. I think thanks for that. But I think it was, you know, since Grenfell, it really started to move quickly into the importance of fire stop, and I think it was a real eye opener. And I think people need, like, it's really changed so that now when buildings are being designed, used to be fire stop was kind of on the side, an afterthought of like, okay, we'll just fire stop these then, you know, it was just a general thing. But to actually form watertight almost seals in these buildings is just incredibly important, like you said. And yeah, that's definitely the way it's moving. And it's even knowing the basics is very important. It is very useful to know the basics, that you'll be able to have that conversation with the installers to make sure that they're being compliant on site as well.
Lovely. Thank you, Owen. Got another message of thanks, and what a great presentation it was from Terence. So Paul Daly is asking, it's a really good overview. Is there a shelf life expiry on the
intrumescent? Yeah.
Yeah, sorry.
As far as I know, there is basically these foams. They may have a long shelf life for ourselves, but we don't know how the user actually will store these foams, because if you have them in cold storage and it's in November, these products might react differently in colder temperatures if they're stored, and then if they're in hot rooms, it just depends. So normally we have a certain expiry for our foams, but then if they're installed correctly, you know, that benefits them. But yeah, there is I think, as far as I know, there is a expiry.
Lovely. Thank you, Owen. I think that's it for the questions. So I'd just like to thank everybody for attending today's webinar. Thank you to Justina and Owen for their presentations, and we look forward to seeing you at the next one. Thanks,
Brilliant.
everyone.
Thanks very much, guys.
Thanks, Owen. Bye-bye.
See you later. Bye-bye.